If you're watching these videos, we've basically just finished lecture 2. That took up 8 pages. Try to keep me organized here. If I don't, I'll have papers everywhere. Oh no. That's a piece for the blooper reel. Try this again. There we go. All right. Lecture 3. If you are taking this course in kind of a traditional 16-week course, this would be kind of your 3rd class period at this point, or at least 3 class periods worth. When I teach a course, it's got 3 class periods worth of material. If you're in the summer, if you're taking a 2-day-a-week summer course, it's probably 1 day worth of material for you. So at least half a week in the summer and a whole week's worth of material in a regular 16-week semester. At least that's how we do it. All right. So we finished up last time talking about coordinate direction angles. That's one tool we can use for 3-dimensional vectors. Here's another tool we can use for 3-dimensional vectors. Position vectors. And technically you could use this for 2D also, but we normally use these in 3 dimensions. So a position vector is a fixed vector that locates points in space relative to each other. So if I'm going from the origin to some point P, for example, so just quickly, Z, Y, X, and I've got, kind of like I did in the last problem, where I've got some vector, we'll say vector F, some force vector. We'll call it R. That's typically what we'll use. Let's call it R instead of some force vector. Sorry. Some vector R, and it goes to some point P out here in space, starting from the origin. Well, that point P, if you dot a line straight down the z-axis till you basically intersect the xy plane, you can measure where this is out here on the xy plane by drawing basically lines parallel to these. So if I draw dot in a line parallel to y, roughly, that's going to intersect at point xp, if you will, or we'll just call it x1. It's going to intersect the y-axis at a point here, y1. If I dot here parallel to the y until I get right above the x point, then I can dot back parallel to the x-axis and find the point along the z-axis, z1, where point P lives. So what we're saying there is point P lives at the xyz coordinate x1, y1, z1. And so I want to find the position vector that describes going from the origin out to this point P. Well, that position vector is actually pretty simple if you're going from the origin. Then it just simply becomes x1 I plus y1 j plus z1 k. So this vector describes what it would take, or what a vector would be if we went from the origin out to this point P living at x1, y1, z1. Now, sometimes we'll have something going from the origin out to some point P. A lot of times, though, we might have, we need to describe a position vector between 2 points. If I need to describe between 2 points. Well, let's draw an XYZ coordinate plane with 2 points on it, and can try to describe XYZ. Try to describe 2 points here. So let's say the first point is down here, just slightly below the XY plane. We'll call this point 1. And we'll say point 2 is up here. It's behind the XZ plane, this being Z. So slightly behind the XZ plane. A little bit in the negative Y direction. Okay, so, and this would be point 2. Now what I'm going to do is I'm going to dot in some lines. I'm basically going to say, well, this one is above, or I'm sorry, this one is below the XY plane. So if I dot a line out here to point 1, right above it, and if I dot a line parallel to the x-axis from the y-axis out to that same point, and then I dot a line down, that will help me kind of locate where this point is. So it's going to be out here at a location x1, y1, and again it has a negative z value. It's below the xy plane. So if I dot here parallel to x until I get under the x-axis, and then I can dot back along the x direction, I can find the point z1 where that guy lives. So point 1 is, again, down below the xy plane, a value of, it's actually minus z1 if you like. And then point 2 is out here. It has a negative y value, but it's positive x and z values. That is bugging me. Again, I apologize in advance. I'm a little rough teaching statics. It's been a few years since I've taught statics, but that's okay. And I have taught it several times. I'm just a little rusty. All right. So let's locate point 2, shall we? Let's say if I dot here in the y direction to where it's right above the x-axis, and then dot straight down, we find its location on the x-axis. We'll call that x2. And I'm out here kind of at the very top of what I've drawn for the z-axis. So you can draw a little taller if you like. We'll call this z2. So it's there at a height z2. And then again, it's out here in the negative y direction. So if I dot here and try to locate along the negative y-axis, it's out here at y2 and negative y2 value. So that's point 2. Okay. Well, your position vector is always going to be final minus initial. So if I have a vector, let's say going from 1 to 2. So how do I do that? I'm going to gently dot in a line connecting the 2. I can tell you from experience it's a lot easier to erase a bunch of little dots or connect a bunch of little dots if you're not really sure the angle or how that line should go. If you dot it in as a bunch of little dots, and again this vector, this is vector r. How do I describe vector r? Well, again, you can dot in a bunch of little dots and then draw a solid line. And this is vector r, but let's describe it mathematically. How would I do that? I would use a position vector. How do I construct a position vector between 2 points? I'm going to go final minus initial. I'm going from 1 to 2. So I'm going to take the values at point 2, x2, minus the value at point 1, final minus initial, and that's going to represent the x component. And I'm going to do the same thing for the others. y2 minus y1 in the j direction, plus z2 minus z1 in the k direction. And that, if I have measurements for these, and yeah, this will be a negative value, so I'll plug in, let's say it's minus 2. I would plug in minus 2 here for y2. And let's say z1 is in the negative direction, so let's say it's minus 1 down here. Well, I would plug in minus a negative 1 there. And this would allow me to mathematically construct a vector describing how far do I go to get from point 1 to point 2 in each x, y, and z direction. So if I had measurements, actual numbers for these points, point 1 and point 2, then I could generate a vector that points what, if I have something connecting, say like a cable or a rope, I could actually describe the x, y, and z components of that cable between the two locations. All right, and so let's say I wanted to describe a force directed along this vector. What I could do is I could take the magnitude of that force, F, and I could say, well, the force vector would be the magnitude of the force multiplied by a unit vector. Let's say going from either A to B, or in this case, just simply R. So I could take the magnitude of that force, and how do I find a unit vector? Well, I would take the position vector divided by the magnitude of that position vector. And that would give me a unit vector, right? Because this has a magnitude R, and I divide it by its own magnitude. So I would get a magnitude of 1 by doing this. That gives me a unit vector in the direction from A to B, or 1 to 2 in this case. And I could just multiply this magnitude multiplied by this unit vector. Well, the unit vector is going to have components. It's going to have direction. So that's going to allow me to describe, if I take this force and apply it along a vector that has the direction of R. Let's do an example, right? And so that's a pretty decent stopping point for this video. I've got an example. I've got a fundamental problem out of the textbook, out of the Hibbeler textbook that I'd like to work. Kind of give us a chance to show this off a little bit, okay? So, like I said, I'm going to break it up and we'll start another video from there.